Hi, welcome to 500 videos. This is DC here. This is the part 5 and probably the last video on Atmel AT88SC102 secure memory card. In this video, you're going to see various operations in security mode 2. The last video, we have made the card set to security mode 2, and that is done by blowing the issuer fuse. And in this video, we are going to see all these read and writes and errors operations you can do. Now you have to be comfortable with the security mode 2 table from the datasheet. In the last video we just had a look at that. We are going to probably discuss that in detail. So you're going to see the working of especially now if you keep this basic read and write operation aside. So the operation which is something different is the erasing of zone 1 and zone 2. And in the last video we have seen the zone 2 erase is controlled by a counter, and we have the counter enabled, and we know that because of that fuse, because of that EC2 enabled fuse, which is not blown, that is which is set to 1, you can erase zone 2 only 128, the maximum 128 times. So there is a bit counter which tracks the number of times the zone 2 is erased. We are finally going to see how to disable the zone 2 erase operations, and we are going to see how to disable the complete write and erase operations. And finally, now when we do this step 4, we'll be having a secure memory card which is only in read-only mode. You cannot write or erase any further. So this is the table we have to be now comfortable with, and in fact this looks pretty complex, but there are very few operations you have to know in security mode 2. So we are going to see that the issuer zone you can only read, and after that the code protected zone you can do the write and erase operation only after the secure code verification. And we're going to see the write and erase operations on zone 1. So for writing to zone 1, you must have the secure code verified, and for erasing you must have the erase code verified as well. We know that both zone 1 and zone 2 have the erase code, which is very similar to the security code. It's a kind of a password, and that needs verified as well. The only difference between the security code and the erase code is there is no negative or a wrong password counter for EZ1. So like we have got the SCAC. This is the counter that tracks how many times the security code has been failed, and that after 4 wrong attempts the card gets locked. So there is no similar thing for EZ1. You can keep trying wrong password forever. There is no auto lock mechanism here. So likewise, you can see here the zone 2 can also be written only when the security code is verified, but we can erase only with the successful verification of the erase key too. And finally we are going to discuss about the erase counter 2 value, which is always, if you look at this these 6 values here, they're all don't cares. That means you can always go and change anytime. So that's exactly what you want to do to prevent the zone 2 erase operations. So with this in background, we'll go and play with this card. So this is the same card we have used in the previous videos, and this card is set to the security mode 2 after blowing the issuer fuse. Now when you try to read this entire card without any security code verification, this is what you say: we cannot read the content of application zone 1, the application zone 2, and in fact you can also cannot read the erase key for zone 1 and erase key for zone 2. However, you can read the erase counter for zone 2, and which, as you can see here, if you add up all the number of bits, it sums to 128 bits, out of which I have already used the first 8 erase counters here, because I have been playing with this card. Now the 8 times I have erased, so you got a remaining 120 times left. So we are going to first verify the password, the security code, which is ABCD, verify. And if you try to read, now I'm able to read the contents of zone 1 and zone 2 data. Even after verification, you cannot read the value of the key 1 and key 2. If you compare this with the security mode 1, where as soon as you authenticate, or as soon as you verify, you can read the value of zone 1 key and zone 2 key, but you cannot do that in the security mode 2. I'm going to first modify this data. Now I'm going to modify the zone 2. Probably now I'm going to change this to say 00. Just change the last 2 bytes as zeros and say write, and you can see the write is successful. So we are able to write to zone 1. I'm also going to do the same thing for zone 2 as well. Right, so we are able to write it. How about the erase operations? Now I'm going to go to zone 2 and erase the, I've changed this label from the previous version of the software. This is now called word number. Word number 1 is the first 2 bytes, the first 16 bits, and word number 2 is the second 16 bits, and so on. I want to erase the last word, so I can change this counter to 32. We have got 64 bytes in zone 1, so the word number will be 32. If you try to erase, now this is something we have added to the software. The software shows erase failed, and the only way you know whether erase is a success or failed is by comparing the value with the FFs. Now after the erase operation, so I'm reading the 2 bytes from this zone. If the erase was successful, the 2 bytes should have a value FFs. However, here it is 0102, which is the original value. So that makes us to show this message AZ1 error failed. So what we just saw is, even after the security code verification, you cannot erase the content of zone 1. It's exactly the same for zone 2 also. Now let's try to do that in zone 2. Erase. So here also the erase is not successful. So in order to erase zone 1 or zone 2, we have to use the application zone 1 erase key verification. Now if you look into the documentation of this particular reader, there is no way you can just verify the zone 1 erase key. So there's one single command. So I'm going to show you in a minute. Now this is the command I have used. This command is called erase application zone with erase, and this command does the verification of erase key, of zone 1 key, as well as it also erases the data. So many things are done using single command. since we are using this API, you have to, there's no other option for us. We just have to use this command which does a verification as well as erase. And the only way the erase is successful or not is by reading that all the bytes are set to FFs. There's no other way. So similarly, there's one more command, similar command, erase application zone with the right hand erase. This also, but this is used to erase the application zone 2, and this is used to erase application zone 1 and 2, but I'm using this command to erase zone 1, whereas this command I'm using to erase zone 2. You cannot use this command to erase zone 1 because the number of bytes you can send here is fixed to 4. Now if you look at the documentation of this card, the number of bytes for zone 1 erase key is 6 and zone 2 erase key is 4. So I have used this command for zone 2 and the first one for zone 1. Again, the documentation clearly mentions you have to look for the value FFs to know that erase is successful. Now going to zone 1. So from the last videos we know that the key values are all A1. You just have to keep noticing the value of, sorry, not here. So this is nothing to do with, because we are playing with zone 1. Now what you have to keep in mind here is this command erases this entire 64 bytes of zone 1. You cannot erase just a part of that. Maybe you can do that later on, but not during the authentication. So I'm going to hit verify and erase AZ1. Now again, the software says AZ1 erase OK, and we got the message by comparing all the 64 bytes to FFs. If you can see here, the content is also showing as FFs. Now this is our zone. If you look at the value of, sorry, here, so let's do the same thing for zone 2. We know the password for zone 2 erase key is A2, and hit this erase. Now everything is set to FFs. If you look at the value of this EZ2, which the first 8 bits are used while I was testing this card, give a read again. You can see that we also used one more bit here. If you enable the binary value and go to this zone 2 erase counter, you can see that, so here the first 9 bits are set to zeros. Now every time you run this erase, I'm going to hit this again. If you see, the values will be consuming one counter here. So totally I have erased 9 times this zone 2. So likewise, so just keep hitting, this keeps setting to zeros. So that is how the application zone 2 error counter works. So in security mode 2 only, whenever you erase with the zone 2 key, you will be consuming 1 bit here. So after we consume all the 128 bits, you cannot erase any further, and that's the main feature of this card. You can limit number of times you can erase. So yeah, I want to, because we have got everything as everything is clear, I can write something. I'm going to write. Now one more thing I would like to let you know is I have introduced all these checkboxes here, and at any given time this will tell you if this SV is ticked, it means the security code has been verified. R1 and P1, they refers to the first 2 bits of the application zone 1 data. So if you look at the binary code, the first two bits. The first bit is R1, the second bit is P1. So R1, P1 refers to those two, and E1 is set whenever the application zone on erase key is verified. This is set. Likewise, R2, P2 corresponds to the first two bits of application zone 2 data, and E2 is set whenever the application zone 2 erase key is verified. Now I'm going to write this thing, change this to say 0, and so try to reset everything to probably no zeros. I'm going to copy the default data here. I'm going to write, get rid of the binary mode. So the write is successful. Likewise, I'm going to set the default value for zone 2 as well. Now at this given time we have E1 is set and E2 is set. As you can notice here, R1, P1, the tick bars have gone because the R1, P1 refers to the first two bits, and R2, P2 refers to first two bits here. So they're gone. So these tick boxes are in sync with the data we write. Now because the erase is already verified, erase key is already verified, I'm going to try to clear off the last two bytes. The last two bytes now. Say erase. Okay. Now what we have to keep in mind here is the only way now to erase the application zone is to erase the entire section. You cannot use this byte arrays or word arrays. So this will be of no use in security mode 2. We just saw that here. Okay. Alright, so I'm going to show you one more feature. Try to insert this card again. See, back in this table we're going to see this line here. So what this says is, without the security code verification we are able to read the content of the memory or content of zone 1. However, you must have the bit R1 set. If you go up here, this is the bit R1. So the R1 is set to 1 and the SV set to 0. Now this feature allows us to make the application zone 1 readable even without the secure code verification. The same thing applies to the secure zone 2 also, where here we will be using this the bit R2. We have reinserted the card again. Connect, choose, select the card, read everything and verify the code. We have verified. Now what I want to do is I would like to set the bit 1 of the first byte to 1 and as well as the bit 1 of the zone 2 to 1. Now I cannot write, if you try to write here, so 0 1, if you try to write, so nothing happens because the byte is already set to zeros, and you know the write operation can never change a bit from 0 to 1. We know that. The only way you can do that is by erasing the entire section and writing this data. Writing this data. Now before erase you have to first verify the erase key, and that is going to consume one more bit here, erase. If you look at this, now this has changed as well. Sorry, I don't know why I'm behind this this counter. So sorry, this counter applies only for zone 2. So I have erased. Now I'm going to change the lower bit to 1, that's here, and say write the lower bit set to 1. If you look at here, the very first bit is set to 1, so we have got R1 is set to 1. Likewise, I'm going to do the same thing for and here also I'm going to set the lower bit to 1. You can see that R2 is set to 1 as well. I may be wrong, so my apology for that, because the first bit is referred as P1 and the second bit is referred as R1, whereas in zone 2 the first bit is referred to as a P2 and the second bit refers to as R2. Now we have to set the bit 2, not the bit 1. So the arrays key 1 is already set, so I can go and modify. I can't write here though, because I want to set the bit 2 to 1. Now I can't go and set 0 2 here. That will not work. Now the only way to do that is erase again. Try to erase this. No, I don't know if you can do that. So you have to use verify and erase. So this erased, I'm going to set, so I'm going to have both the R1 and P1 set to 1. So I'm going to use 0 3, where is binary 1 1. So right, so I got E1, the first two bits E1, R1 and P1 set to 1 1. So I'm going to do the same thing for zone 2 also. First erase and set 0 3, the write operations. Okay, yeah, so we have got R1 P1 R2 P2 set 1 1. So I'm going to remove this card. So close the screen and try to read the entire tag without verification and see what we get. So we are reading this entire card without verification of the password. You can see that this time we are able to read the content of zone 1 and zone 2, and it is possible because of this entry in the table. So we are able to do the read operations because of the second entry. So where the SV is 0 and E1 is 1, and here also SV is 0 and this E2 is 1, we are able to read and read. So next I'm going to show how do we disable this arrays completely. So for you can't stop the arrays happening from zone 1. You can do only for zone 2. It's pretty straightforward. We just have to set this entire 128 bits to 0. If you look at this table, in order to change the value of EC2, you can write this anytime without any password verification. You can see that this is set to X, and you can't erase though. Probably you can write. There's no erase operation. Write it. We'll try to erase this and see whether it works. So I'm going to erase. Okay, probably this could be a copy paste error. So erase word 4. Here, because the word 4 is already FFs, the software says is S. So I'm going to clear this all to zeros. Just bear in mind, you cannot use a write operation to change a bit from 0 to 1. So I'm going to set all these 128 bits to zeros now, right? Now the write is done. We'll try to verify and see what's going to happen. So ABCD, verify, read entire tag, go to zone 2. So we know the password is A1, sorry, A2. Now try to verify and erase. The erase failed. We get a different code altogether. So what we just saw is you cannot erase zone 2 anymore because all this zone 2 erase counter bit set to 00. And you just have to keep in mind here before I close this video. Now we are able to do this, control the erase application zone to erase counter. It is because we did not blow the fuse called EC2EN. We did not blow this fuse. If you blow the fuse and set to 0, so this makes even the application zone 2 erasable a number of times, just like application zone 1. So finally we want to make this card read only. Now it's a very straightforward thing to do. We just have to set this security attempts counter to zeros. Now this is the one that controls, you know that this card allows you to have only 4 wrong attempts. You can either go here and verify with the wrong code 4 times, or you can just go and write this. Let's see both. I'm going to probably just try reinserting. If you take a look at this entry in the table, you can see that anytime we can write to this zone. You don't need any verification of the code. So I'm going to try both the ways here. First I'm going to authenticate, verify with the wrong password. Verify. You can see that we already lost the one attempt here. Just go to set in the binary mode. We lost one. Verify with verify. Again we lost 2 bits. Now I'm going to write this code, write it as 00. I'm going to set all zeros. Some documentation says you can use this the second byte for any data, because only the first 4 bits are used for the counter. Say write. Now we have got the counter set to zeros. I'm going to now authenticate with the correct code. Verify. The verification fails. So from this point onwards, this card has become a read-only card. We cannot modify and we cannot erase. I think that's all about AT88SC102 memory card. So we have altogether 5 videos. I hope this videos has given enough information so that you can experiment, or you're on your own now. So with this background, as I mentioned before, the ultimate goal of this video series on Atmel is to understand the crypto card 104C. But before that, I'm going to have 2 more video series on the Atmel 153 and Atmel 1608. By the time we finish these 2 memory card, I'm sure you'll be prepared for, or the 104C card will be easy for you. Okay, thanks for watching.